Okay, it's just easier to make a video response to this comment real quick. Auto upload, audio synchronization issues, we'll see. Okay, from Just Nobody. I was talking about if there's an n-dimensional reality, and we think we're in a three-dimensional reality because we're taking cross sections. You know, it's like when you take a camera picture and take a picture of something, a camera picture, and you take a picture of something, you've taken a projection, right? It's a 3D thing, but it's projected down to 2D. It's always like that with the measurement device. All our senses, therefore, are taking some sort of a projection. And if you have enough projections, you can get 3D information. You know, if you have two projections or a bunch of projections, even though each one's 2D, you can get a 3D model. Okay, so you can bring your dimensionality up. But still, the basic thing is that any measurement device is doing this kind of a taking a projection thing. Think about it. You know, it collapses down some more complicated information into just one little number. So, that's what we're talking about. Now he says the normal things that you would associate with our reality being a subset of a higher end ND reality simply do not happen. Well, that's funny too. The normal things, you know, they're surreal. But yeah, the things that you would expect to happen possibly if there was an n-dimensional. Objects don't disappear and reappear, but they do. And the quantum, and that's the whole quantum vacuum thing, is that things do appear and disappear. That's the funny thing. If you think that they're not really appearing and disappearing, that's why you need the n-dimensional space. But they do, and look into the quantum mechanics. There's plenty of examples of this type of thing. Now, energy is conserved. Yeah, I think somehow that word would work in the n-dimensional space as well. You don't see objects rapidly change form. Okay, you don't see objects rapidly change form. Well, I don't know. What about matter, antimatter, annihilation, and all the nuclear, the spontaneous? See, again, we're talking quantum mechanics. It does show all these things. That's why we're facing it, because quantum mechanics is real. It's been around a century or so, and you could just face that we have seen those effects. You know, we have seen that n-dimensional reality in the two-slit experiment, where we see the effects of a wavefront going through both slits at once, even though it's just one photon and one speck particulate appears. Again, that speck is some sort of a cross-section of a bigger phenomena. If you, in that model, I mean, in that experiment, I mean, I don't know how else you're going to model it, because in some sense, you have this higher dimensionality, whether it's imaginary numbers, and so that doesn't really count, it's just there mathematically. Well, it is necessary mathematically to explain the phenomena. So if the reality was really just three-dimensional, why would you need some higher dimensional concept to explain it? Now, we don't know. I don't say that we know that that's the case, but you say there's no evidence, and there is, as we have to face that evidence from quantum mechanics.